In this lesson, we're going to look at how to find the volume of prisms. So if you look at the first example here, and when we talk about finding volume, we're talking about the space inside this three-dimensional object. And when we measure volume, it's always going to be in cubic units. And that's because of the fact that you're taking a dimension times a dimension times a dimension. So if you look at this problem, you would be doing centimeters times centimeters times centimeters, so centimeters cubed. And we usually write that as the unit to the third power. And then when we look at this first problem here, this first example, the formula that you see is volume equals length times width times height. So this is something that you saw back in middle school. You probably just wrote it as volume equals length times width times height. So if I were to actually solve for the volume of this, it doesn't really matter what you call the length, the width, and the height, but just to kind of the way that this is lined up, I'm going to call this the length and this the width. So I'm going to do 5 times 4 times the height, which is 3. So this is going to end up giving me, so 5 times 4 gives me 20, times 3 is going to give me 60. And my units would be centimeters cubed. So that's what you saw back in middle school. In geometry, we're going to extend prisms to being able to find the volume of a hexagonal prism or a triangular prism or a trapezoidal prism. So we're going to change the bases. They won't necessarily just be rectangular prisms or a box. We're going to look at different shapes for the bases. So one thing to look at here to notice is that when you really did length times width times height, you can still use that when you are dealing with rectangular prisms. But really what we did was we took the area of the base, so length times width. So if you imagine this base down here, so if I called these the bases, the top and the bottom, I took the area of the base, so length times width, and then I just multiplied it by that third dimension. So we can use that idea to kind of extend our volume formula for prisms to any type of prism. So if you look down below here, here's the formula that's going to be more helpful in geometry. We're going to say we're going to multiply the area of the base times the height, and that will give us the volume of the prism. Shortcut or the formula version that you'll see it like this with a capital B. Notice that it's a capital B. In math, anytime we use capital letters, it means there was a calculation done. So if you think about volume, it's a capital V because it was a calculation done. Perimeter, capital P, there was a calculation done. So the capital B stands for the area of the base. So don't get that confused as lowercase b, which would be the length of the base. So capital B is the area of the base. So what we're going to do is if we look at this first example, it's going to be important to understand, first of all, where are the bases? So what are the bases? So the bases, keep in mind, must be parallel to each other. They must be congruent, and they will always be connected using rectangles. So the lateral faces are going to be those faces that are connecting the two bases, and those will always be rectangles. Bouncing back to this first example, it doesn't matter which pair of rectangles I choose as my bases because in the end, it's going to be the same formula. All of the shapes are rectangles, so you're going to be using length times width for those areas, so it wouldn't make a difference. However, when you get down to this trapezoidal prism, the bases, it's very important that you identify those correctly. So the bases are going to be parallel to each other and they have to be congruent, and all of the other faces are then rectangles, and those are called the lateral faces. So if I look, the bases here are these trapezoids. So that's why I'm calling this a trapezoidal prism, because these right here, these trapezoids represent my bases. So that's important. So I'm just going to highlight those just to represent that. So then what that means is if I want to find the volume of this, I'm going to be doing the volume equals capital B times H. So capital B is going to be the area of this trapezoid. So let's think for a second, area of a trapezoid, that formula. So that's going to be 1/2 base 1 plus base 2 times the height, or you can think about it as base 1 plus base 2 times the height all over 2, doesn't make a difference. So let's go ahead and think about what I would be plugging in. So now we're focusing just on the trapezoid. So imagine this orange trapezoid here or behind. They're congruent, so it doesn't make a difference. So I see my bases of the trapezoid are the parallel sides. So we are kind of doing some assumptions that those are parallel. But the problem talks about a pool. This is modeling a pool, so we're going to go ahead and assume that those would be parallel. And I'm going to say that those are going to, so the bases are 10 and 4, right? So this is going to be B1, this is going to be B2. So my area of my trapezoid is going to be 1/2. So base 1, doesn't matter which one you call base 1 and base 2. And then times the height. So this is where you have to be careful because our formula really has two H's in it. It has the height of the prism, which will be used for volume, and then the height of the trapezoid. So the height of the trapezoid is the distance between the two bases. And again, I'm assuming that this right up top here, I'm assuming that there's a right angle here because of this being a swimming pool. And this part down below is the diagonal. That is not perpendicular because that's the different depths of the pool. So the height is going to be 30. So now I'm going to do 1/2 of 14 times 30. I'm just going to go ahead and type that right into my calculator, or you're really just doing 14 divided by 2, so 7 times 30. So that gives us 210. And notice that this is an area, so this would be feet squared. But now what I'm going to do with that area is I'm going to plug that in up top. And feel free when you're doing these problems, if you would rather just do one big formula, and sometimes I'll do it that way, where I just do one big formula and like meaning I plug the area formula right into the volume formula. That's totally fine. Sometimes trapezoids though confuse people a little bit, so I thought doing the area separate and then plugging it in would be a little bit less confusing, but it's really just a preference. So it's totally your call on that, how you want to go about it. So I have the area of my base is 210. Now I'm going to multiply that by the height of the prism. So the height of the prism not necessarily is the up or down. Remember, height doesn't have to be up or down, but it has to be that perpendicular distance. So when we talk about the height of a prism, it's the distance between the two bases. So it's the distance that connects these two bases. So it's this distance, and it's going to be perpendicular to those bases. So it's going to be the 15. So the 15 is the height of the prism. So this is going to be 15. And now I'm going to go ahead and multiply that. So this is 210 feet squared times 15 feet. So I'm doing feet squared times feet, which is how I'm going to get feet cubed. So I'm doing 210 times 15, and that gives me 3,150 feet cubed, or cubic feet. So that is the volume of the pool. I just want to make sure too that we've answered the question. So a common design, it talks about the pool. Use the dimensions shown to find the volume of water the pool can hold. So there's your total volume, assuming that we're going to fill it all the way to the top, which you do need to make that assumption here since it doesn't state on otherwise. So we're just finding the total volume. So that's it for that one. Let's try one more, and this one's kind of working backwards. So like example 1, you're gonna see different problems where the bases are gonna get switched up, and we're gonna do much more practice with this in class. But example 2 is a little bit different because if you look at what happens in this problem, it gives us the volume. It tells us that the volume of this rectangular prism is 6,000 cubic feet. We want to find the surface area. So now we're thinking, instead of just finding the volume of a prism, we're actually going to use the volume to then find the surface area. So area means if you're trying to find the surface area, you're trying to find the area of all of these rectangles and then add it together. You want the area of the total surface. So first of all, I need to know some dimensions, because if I want to know the area of all of these surfaces, right now I'm missing this dimension right here, this x. And I would need that to be able to calculate the area of this rectangle on top, as well as the front and back of this box. So using my volume formula, you can use capital B times H, the area of the base times H, But honestly, more people, when it's a rectangular prism, would rather just go back to length times width times height, because that always works for rectangular prisms. And it really is this formula. We're really just taking this capital B and we're just writing it as length times width. So it's up to you which one you want to use. Either way, you're going to end up with the same thing. So now I'm going to plug in what I have. So I have 6,000 for the volume. The length, it doesn't matter which one you call length, width, and height, because you can rotate this around. It's all going to change. All three numbers get multiplied. But let's just say I call this the length. So that's X. I'll call the width 20, which then means the distance, if I'm calling this the base, and then this down here is the base, that means the distance between the bases is going to be right here, which is the height, which is going to be 30. Again, you just need to multiply the numbers. So I'm going to go ahead and multiply the 30 times the 20. That's going to give me 600. So I have 6,000 equals 600 times X. So to solve for X, we're going to divide by 600. And when we do that, we end up with 10 for X. So I'm going to go ahead and just put that right back in the picture. So that'll be 10 feet. And now what we need to focus on is surface area. So you won't see a lot with surface area in this unit, but occasionally you will. So surface area is just the area of all the surfaces. And keep in mind, it'll be units squared for surface area because of the fact that you're dealing with area. So it's just length times width, and then you're just going to be adding it all together. So for surface area, we have to think about what shapes we have. So we have, in this situation, since this is a rectangular prism, I have all rectangles. Maybe some are squares, but let's just call them rectangles. So I know that the top and the bottom of this rectangle, or of this rectangular prism, I need to find the areas of those. So I'm just going to say surface area equals, I'm not going to really worry about writing a formula. I'm just going to go ahead and plug in. There are formulas for these, but honestly, it's easier just to find the areas of the individual shapes and add them together. So I know that there's 2 of those rectangles on top and the bottom. So it's going to be 2 times the area of the top and the bottom. So this is going to be 10 times 20, length times width. So I'll just write up here as my formula for rectangle, length times width. That's what I'm using. Plus, now I have to do the area of, let's say, the front and the back. Let me pick a different color here. So the front and the back. So there'd be this front box and then the back box here that you can't really see now. It just looks like a scribbled mess. But this is going to be 10 times 30, the front and the back. So 2 of those. And then the last piece that I need to do are the sides. So I never did the sides. So the sides are 20 by 30. So there's going to be 2 of those as well. So 2 times 20 by 30. And then we go ahead and we do some calculations. So maybe do, you could type it all in. You could do the pieces individually, whatever you feel most comfortable with. I'm going to do them individually just so that you can kind of check. So 2 times 10 times 30. So 600. And then 2 times 20 times 30. So 1,200. And then I'm going to go ahead and add those up. So I have 1,000 here plus 1,200. So that'll give me 2,200. And again, that's going to be whatever the units are squared. So in this case, feet squared, because we're talking about area. So you really only ever multiplied feet times feet. So that's why it's not cubic feet. All right, so that's it for the video. So go ahead and try the check your understanding problems. And like I said, we're going to do much more practice with identifying bases and finding volumes in class.